Hello and welcome to today's lecture. This is part 2 of set theory, and in part 2 we are going to see set operations. But before seeing the operations on set, we need to define one more definition, and this definition is the universal set. Remember, we said that in set theory the name of a set describes the elements of that set. So a universal set, from the word universal, is a set that contains all the elements under consideration. Is a set that contains all, underline the word all, the elements under consideration. That is a universal set, and in most cases you are given a universal set. In some cases you are given several sets and asked to define a universal set. And another last definition that we had forgotten is the disjoint set. From the name disjoint, it means these sets don't join. Now our definition is if two non-empty sets, we have two non-empty sets. If they are non-empty, it means these sets have elements. We're having two non-empty sets, A and B, are said to be disjoint if they have no element in common. If they have no element in common, meaning we have two sets which have elements and none of the element in A is in B. Let me just give you an example, because let's say you have a set X, a set A, it has element X, Y and Z, and then we have set B. Set B has elements 1, 2, 3 and 4. You can see that these two elements are different. That means these two sets, A and B, will be called disjoint sets. In short, it means they cannot be joined by any set operation. Now we are going straight to our set operations. We're going straight to our set operations. Operation on sets. We have the following operation on sets, which we're going to consider, namely the union, intersection, complement, we have set difference, and lastly, the last operation is the symmetric difference. We are also going to look at the Venn diagrams. As we're going to handle the set operations, we also look at the Venn diagrams to know how these sets behave. And right on it, we're going to start with the union. The union of two sets. A union of two sets A and B is a set that contains all the elements of set A and all the elements of set B. So we're going to write the union. Let's just define it here. The union of two sets. Let's say you have two sets A and B, is a set that contains all the elements. Is a set that contains all the elements of A and B, that contains all elements of set A and set B. That's the union of two sets A and B. And how do we write it? We say A union B. We are going to write the curly brackets. It has elements X such that X is in A or X is in B, meaning this set has all the elements of A and B. And if you are to draw a Venn diagram to represent the same, we are going to have this box. All the other elements here are the U, and then we have two sets. Let's say set A and set B. This is set A and this is set B. So you're having an element X such that X can either be in A or X is either in B. And now when you're shading, you shade everything because we don't know where X is. X can be in A or X can be in B. So this is B and this is set A. So if you're going to draw a Venn diagram for the union, you shade everything for set A and set B. Okay, that's the first set operation. Our next set of operation, but now before that, let's check an example. Say we have, sorry about that, say we have two sets. Let's see how we will get an operation. Say we have a set A. We are given set A is 2, 5, 6, 7, and we are given set B, and this set B has elements 4, 7, 9, 8, 10. Then you are asked to find A union B. What are you going to do? So we have said it's either in A or in B, and we have said also that it contains all the elements in set A and all the elements in set B. So simple thing is the union is like addition. We are going to take everything in set A and everything in set B. 4, 7, 9, 8, 10. But now this set, you can realize 7 is twice, 4 is not aligned properly, so you can write it properly as 2, 4, 5, 6, 7, 8, 9, 10. A clean set. There's no need of repeating twice because 7 element set A has element 7 and set B also has 7, so you just write 1, 7. That is A union B. Our next operation is the intersection. This is operation 2, is called intersection. Intersection. So the intersection of two sets A and B. The intersection of set A and B, let's define so that you will be able to use the definition to solve the problem. The intersection of set A and B is the set that contains all the elements that are both in A and B. That contains all the elements common to the two sets. Intersection only deals with the common elements. What does common mean? If that element is in A and that element is in B, it's an element you are going to pick. And now we are going to denote intersection by A intersection B. And now if you're going to define A intersection B, it's a set, you're using curly brackets, X such that X is in A and X is in B, meaning X must be in both A and B. How do we write the Venn diagram? Assuming you're asked to draw this Venn diagram, what are you going to do? We have this box, we have said represents the universal set as we have defined, as all the elements under consideration is the universal set. But now our main interest here is the intersection. We have set A and we have set B, and our definition says that it must be in A and in B. So we shed this part. Let's just if we draw this properly, let's say this is A and B. We are going to fix. That means we have our A, we have our B. Only this section contains the X that is in both in A and in B. For example, and I don't mind about the diagram, drawing freehand is sometimes quite challenging. Let's say we have a set A which has the elements that we are going to list below. That is set A. We have set B also. It has some elements 4, 6, 8, 10 and 12. And now you are asked to find A intersection B. What are you going to do? We have said X is in A and X is in B, meaning X must be in A and B. You begin checking. Is 1 in B? No, we leave 1. Is 2 in B? No. Is 5 in B? No. Is 6 in B? Yes, you write 6. Is 8 in B? Yes, you write 8. Is 10 in B? Yes, you write it. So you find that our A intersection B has only 3 elements, 6, 8 and 10. They are found in both A and B.